Hello, everyone. I'm Sumudu Senanayake. My presentation is on soil erosion monitoring in support of achieving sustainable development goals. The overview of the presentation, introduction, background, and problem identification, aim and the objectives, methodologies followed by results and conclusion. Introduction. Health farming system play a vital role in sustainable food production. Soil is a critical factor for healthy farming system and to achieve the sustainable development goals of the United Nations. This image shows the cropland distribution in the world developed from the Landsat satellite imageries in 2015. As we all know, there are 17 sustainable development goals. The soil play a key role in the enabling the sustainable development goals. Many SDGs refers to the targets that directly consider soil resources. These are some of the SDGs supports for the considering soil resources, and all the SDGs are depend directly and indirectly on the provisions of ecosystem services. However, unsustainable use of soil can lead to the specific soil degradation, such as soil erosion, compaction, contamination, and decline in soil organic matter, loss of soil diversity, and others. Soil threats include the soil organic carbon changes, nutrient imbalance, soil compaction, soil erosion by wind and the water, soil biodiversity losses, and desertification and landslides. The water erosion greatly contributes to the soil erosion hazards. There are several types of land degradation. However, 50% of global soil erosion is caused by the water. The water erosion has identified as a major threat to agriculture land degradation. The aim of this study is to monitor the soil erosion at farmland using different tools and techniques such as index-based method, statistical tools, machine learning algorithms to detect and quantify the soil erosion to improve the land productivity and food security achieving SDGs. The problem identification. The farming system in tropical regions, especially South Asian countries, are highly vulnerable to climate change, low crop productivity, and food insecurity. Sri Lanka, which is one of the South Asian country, was ranked in the top 10 countries consecutively in the recent years in the Global Climate Risk Index. What is this Global Climate Risk Index? That indicates to what extent countries and regions have been affected by extreme climate events. Sri Lanka is experiencing drought, floods, and landslides every year. These are some of the pictorials gathered from the literature, and at the bottom of the slide, you can see the graph indicate number of landslides happened during 2003 to 2017, and the red color indicate the number of deaths happened due to these landslides events. Approximately 30% of the area, total land area is highly susceptible to landslides, including the central region. So we selected the Central Highlands for this study. And 4 approaches were used to assess the soil erosion in achieving the sustainable development goals. And the first methodology, we used several assessments including land use, land cover change, and crop diversity change, soil erosion, and soil erosion hazards assessment. And several vegetation indexes were used to assess, and land use, land cover classification derived 6 classes, and the land use, land cover change indicate that the dense forests and less dense forests are decreasing, while cropping area and build-up areas are increasing. The increasing cropping area is a great threat for the achieving sustainable development goals. And also we observed the soil erosion is increasing from 2000 to 2019. In 2000, it's 9.08 tons per hectare per year, and it is reached to the 11.08 in 2019. The crop diversity change indicate there's a decreasing trend. Crop diversity change was assessed by using various vegetation indexes such as NDVI, SEVI, and AVI. For further assessment, we used the landslides to identify 3 farming systems. 2 are highly vulnerable for landslide incidents. 1 is moderately vulnerable. And all these farming systems indicate increasing trend of NDVI and AV indexes. So we further analyzed and we used the rain use efficiency index, which is an indicator for land degradation. So we observe that 2 farming systems which are highly vulnerable, it's a negative trend that indicates the land degradation, while other is a slightly positive trend. In addition, we analyze to find out whether this is a climate-induced land degradation or human-induced land degradation. For that, we use restraint indicator. It is indicate whether it's a human-induced land degradation, and we observe all these 3 farming systems, the positive trend that indicate improvement of the vegetation conditions. So we suggest that because this land degradation is due to climate related degradation. The monitoring results that increase in soil erosion is observed in this region, and as we all know that that because of increase in soil erosion, agriculture production increase the sediments in water resources, and increase the soil erosion hazards. So that the strategies, the implementing strategy is that implement targets the activities related to target 2.4 and target 6.3 as well as 13.1 activities to measure to manage the soil erosion. In target 2.4, it's activities related to implement resilience agriculture practices that increase the productivity and production. By achieving these activities, we can get the outcome increasing agriculture production. So that supports to the SDG goal 2. And as well as the target 6.3 that improve the water quality by reducing pollution. That outcomes will be decrease the sediment in water resources, so that we are supporting to the SDGs 6 as well as 14. And 13.1 that target the activities related to the strengthen the resilience and adaptive capacity to climate related hazards and natural disasters. So that support to the outcome, achieve the outcome decreasing soil erosion hazards, and that ultimately support for the SDG 13 and 14. In the second approach, we used to find out the rainfall variation and use several indexes, extreme rainfall indexes, rainfall anomaly, as well as rainfall trend analysis. So we use the gauged rainfall data as well as satellite rainfall data. That innovative the test results of the innovative trend analysis showed that there's a statistically significant increase in rainfall trend during 2000 to 2019. And some of the extreme rainfall events shows that there's a significantly increase in rainfall trend in this area, rainfall intensity in this area. And the results, the monitoring results, that is increasing rainfall, resulting to enhance the soil erosion hazards in this region. Implementation strategy is the activities related to target 1.5, 2.4, and 13.1 to measure the mitigate the soil erosion hazards. The target 1.5 is related to building the resilience of the poor and host their vulnerable situations and reduce their exposure to vulnerability, climate-related extreme events, and other economic, social, and environmental shocks and disasters. By achieving these activities, so outcome will be the decreasing soil erosion and improve the resilience on soil erosion hazards. So other activities related to target 2.4 and 13.1 that ultimately the outcome support to achieve the SDG 1, SDG 2, as well as SDG 13. Most of these results, the analysis were published in the outcomes published in the Journal of the Science of the Total Environment under the spatial modeling of soil erosion hazard and crop diversity change in rainfall variation in the central highlands of Sri Lanka. The next approach is to find out the ecologically viable and economically sound farming system in this region. So we used the index method to monitor, and several indexes are used, ecological as well as economic indicators, and we use the indexes, and finally the matrix, the results of the matrix used to rank these farming systems to identify very poor and farming systems as well as very good farming systems. So we found 50% of the farming systems are moderately moderate. So 2 farming systems are highly in very poor conditions. The economic and ecological status of the farming systems were identified based on soil erosion from this analysis, and the strategies will be the activities related to target 2.4 and 13.3, that is 15.3, as a measures to improve the very poor status of farming systems for sustainable land management and increase the food production. By achieving these activities, we will be able to get these the outcomes, that is increased food production through sustainable land management of farming system to ensure food and nutrient security. So that support to achieve the SDG 2 and 50. More details can get this analysis from this article, that is proposing an ecological, viable, and economical sound farming systems using matrix-based geoinformatic approach, published in the Journal of Science of the Total Environment. The final approach was using the machine learning and deep learning method to predict the vulnerability of these farming systems for the soil erosion hazards. So we used climate scenarios, that is RCP 2.6 and RCP 8.5 for this analysis. And the results, we found that the farming systems of the Central Highlands will be more vulnerable to soil erosion under climate scenario RCP 8.5 in 2030. The implementation strategy, the target 1.5 and target 2.4 activities, implement these activities and measure to reduce the vulnerability of the farming systems. The target 1.5, building the resilience of poor and hostile vulnerable situation and reduce their exposure and vulnerability to climate-related extreme events and the economic, social, and environmental shocks and disasters. In the 2.5 targets, ensure sustainable food production system and implement the resilient agriculture practices that increase the productivity and production. So outcome will be the improved the vulnerability and resilience of the farming system by 2030 to reduce the climate-induced soil erosion hazard and increase the food production for food and nutrient security. So by achieving these outcomes, we are supporting to the SDG 1 and SDG 2 in 2030. These results will also be published in the Journal of Environmental Management. Further details on this assessment can be obtained from this article. In overall, this study, these monitoring assessments supports to achieve this six sustainable development goals. In these orange color indicate that there's actually 7 SDG goals are supporting this study. Conclusion. The farming system in the western part of the Central Highlands are ecologically and economically degraded and highly vulnerable to the future climate hazards. The soil erosion rates and the vulnerability predictions indicate that the most vulnerable farming areas will be more vulnerable if proper mitigation measures, resilience building activities, and policy level decisions are not introduced. The monitoring the soil erosion at the farmlands using different tools and techniques help to detect and quantify the soil erosion and soil erosion hazards. That results help to find the suitable implication strategies and to improve the land productivity and ensure food security by achieving sustainable development goals. Thank you very much for your attention. I'm happy to answer any questions.